Hello together, welcome to today's webinar hosted by the Open Telekom Cloud community. This time we are having Ferenc with us here in the call. He is part of the Big Data and AI squad of the Open Telekom Cloud, and today we have prepared the topic Introduction to the AI Image in Open Telekom Cloud for you, and you will be here together with us around the next 50 minutes, 55 minutes around. And then I will lead over to Ferenc.
Thank you, Stefan. Hello, everyone. My name is Ferenc Kukucska. I've been working in the Big Data and AI squad for 2.5 years now as an architect and have been in the AI industry since 2017. In the past 5 years, I worked on projects like recommendation systems built on university studies, intelligent search engines, smart camera systems, Raspberry Pis, usage of these smart camera systems, chatbot development using natural language processing, and many other interesting AI tasks. Nowadays, I'm getting involved in more and more DevOps projects. These are my colleagues with whom I worked in the upcoming 2 big projects I will present to you in the session. Zsolt Nagy is a senior architect. He's proficient in AI, big data, DevOps tools like Kubernetes, Helm, Ansible, while Vinit Pruthi is an architect like me. He's proficient in CI/CD pipelines, Jenkins, GitLab, Python, and Terraform. This presentation has 2 major parts. The first one is about creating and provisioning the AI image, what environments we created, a few words about the different deep learning frameworks, their libraries. I have 2 videos recorded, how they can be installed, deployed, and used. This will be a bit tech heavy and mean more to those who already work with these technologies. It will take about 10 or 15 minutes. And if we look the demo with the layman's eye, then in the second part, whose title is Futuregun, this will be much more interesting, exciting, and groundbreaking for all audiences, so please stay tuned till the end. AI image. This project started with a request from our PO that there is a huge demand for different pre-installed usable AI environments that save all the time for developers, AI engineers, data scientists of installing a lot of packages, libraries, Conda and pip environments. So instead of these, they could 100% concentrate only on the development phase of their work. So this means that they don't have to deal with conflicting versions, matching libraries, GPU support. So for those who used any of these packages listed in the right side of this slide, I'm sure they know what I mean. So with my colleagues, Zsolt and Vinit, we created an ECS, an Elastic Cloud Service image with Ubuntu operating system. ECS this is the same as EC2 in AWS. It's basically just a virtual machine, a virtual server. On this virtual machine, you will see that just create one and immediately then we can train models, experiment with the new algorithms. Even JupyterLab can be used with all the well-known open source deep learning frameworks, ByTorch, Tensorflow, MXNET, Chainer, Horwood, and so on. So this AI image is now available in the German, and also we are testing it in the Netherlands region. To prove this, I will present 2 demo videos. One of them will create an ECS VM in EUDE. The other one is the UNL. Almost everything will be the same except for the location. So when deciding which frameworks to choose, we try to focus on the most widespread, well-known and popular AI libraries. That's why we chose TensorFlow, PyTorch, and MXNet. The versions were tougher nut, but we focused on the most widely used TensorFlow, PyTorch, and MXNet version, one older for the legacy applications, and one newer from the current stable version. So let's dive into them. TensorFlow 1.15. So the first one is the good old TensorFlow. As you can see, many of you know it was originally developed by the engineers and the researchers at Google. These bullet points tell you all the essential steps we did to create this Conda environment. As I said a minute ago, we wanted to include an older and newer version of each AI framework, so it was no question that we include a native TensorFlow version that is still being used nowadays by a lot. So that's why we chose TensorFlow 1.15. As you can see from the installed packages, we added all the TensorFlow related libraries, like the basic TensorFlow that uses CPU, the TensorFlow GPU, which utilizes the GPU cores of your computer. So if you want to deploy your TF model, TensorFlow serving is a must-have. It's flexible, high-performance serving system for TensorFlow models designed for production environments as well. As you know, Keras is not part of the native TensorFlow. That's why we install it separately. Chainer is also present. I will tell more about it on the different side. MXNET and MXNET GPU version are also present, as you can see at MXNET CU 101. CU means CUDA. So CUDA stands for Compute Unified Device Architecture. It's a parallel computing platform and application programming interface, so API, that allows software to use certain types of graphical processor units, so GPUs. The most difficult part was integrating this package called Horovod for every 6 environments. I will describe it on a separate slide. We have also checker scripts, as you can see, to test if these packages have been installed properly or not, and we even have a little example script. It's a short training where we use the well-known Boston housing dataset. TensorFlow 2.7. So as you can see, TF2 is almost the same as TF1 with some small differences like the version numbers. TF2 natively supports Keras, so that's why we cannot see Keras in here. Horovod, MXNET, Chainer are also present, but this time with TensorFlow 2.7 support, and among the example scripts, Boston House is not there, as you can see, but we have the good old MNIST training, so you can test TensorFlow 2.7 with training the MNIST dataset. If you pull the repo from GitLab, you can immediately test it and use TensorFlow 2.7. We will have a video for that as well. So the next one is TensorFlow Competitive. This is another great AI framework. It's called ByTorch or Torch. It was originally developed by the Meta AI, aka Facebook, but now it belongs to the Linux Foundation. PyTorch is a Python package that provides 2 high-level features: the tensor computations, like NumPy, with strong GPU acceleration and deep neural networks built on tape-based autograd system. We installed PyTorch 1.6 with QDNN, so it supports GPU, and it also supports the distributed training because Horovod has been installed as well, as you can see, for PyTorch 1.6, and you can check if Horovod and PyTorch are present with our checker script. And start the simplest training on the CIFAR dataset. There is not much difference between PyTorch 1.6 and PyTorch 1.10 except for the version numbers again and the usage of Torch Vision, which provides the very useful tools for image manipulation, image classification. We also have JupyterLab in here and QDNN for the GPU support, and again the CIFAR training, CIFAR dataset. MXNET. So MXNET says about itself that it's open source deep learning framework suited for flexible research prototyping and production. So MXNET's developers is the Apache Software Foundation, and we have version 1.6 and version 1.9 from MXNET. Let's see the Conda environment MXNET 1.6 first. So compared to PyTorch and TensorFlow, MXNET's main appeal is said to be that the scalable distributed training and performance optimization in research and production is enabled. Yes, you can guess by Horovod. And that MXNET has 8 language bindings integration, deep integration into Python. And these are Julia, Scala, Clojure, Java, C++, R, and Perl. MXNET 1.9 Conda environment has, again, version numbers that are different, and we have MNIST demo here as well, and of course the GPU support, QDNN and MXNET CU 112, as you can see. These have been installed using the checker scripts. You can test the Horovod MXNET and the MXNET library as well. So the other good features of MXNET are the NumPy-like programming interface, and that it's lightweight, memory efficient, and portable to smart devices because the native cross-compilation support on ARM. Horovod. So after the main 6 environments comes the much talked about Horovod. Horovod is a distributed deep learning training framework for Tensorflow and Keras and ByTorch and MXNET. So Horovod was originally developed by the car sharing company Uber to make the distributed deep learning fast and easy to use, from bringing the training time from days and weeks to hours and minutes. So the best features of Horovod are that it's fast. So it scales up to hundreds of GPUs with upwards of 90% of scaling efficiency. It's easy to use, so it scales your model training with just a few lines of Python code. It's portable, so it runs the same for TensorFlow, PyTorch, Keras, and MXNet on-premise, in the cloud, and on the Apache Spark as well, and it's open source, of course. Chainer is probably the less known library among those I mentioned so far, but I wanted to cover a couple of things about it. So it's a flexible framework for neural networks. Most of these bullet points don't really need any explanation. The one thing that I want to unfold is the define by run schema, as you can see in the fifth bullet point. So there are two major concepts, the define and run and the define by run. So the first one, define and run, is used by static graph workflows, static graph frameworks. It means that the computational graph is the same for every iteration. So TensorFlow, Microsoft's cognitive development toolkit, and Caffe belongs to this category. And the other one is the define by run schema, as you can see on this slide. It uses dynamic computational graphs. So the graph is allowed to change in each iteration. So Chainer and PyTorch belong to this group. I think this is the most important thing to take home with you regarding Chainer. OTC LabEnv. So OTC LabEnv is a bit of a black sheep during this Conda environment. Since it's not named after a learning framework. It contains the JupyterLab environment, which is commonly used by data scientists, but many other developers also use it for creating prototype codes. It's extremely simple to use in OTC LabEnv. You just have to activate the Conda environment, as you can see under the checker script bullet point. So Conda activate OTC LabEnv, that's it. So the OTC LabEnv is already activated. Then you have this JupyterLab command. You just have to enter that with specifying the IP address and the port number. You will get a token from this, and then you can immediately see in your web browser that the JupyterLab is present, and you can begin the coding there. I will present this in the upcoming video. So we can split the whole setup process into 5 major parts. First, we are going to create the ECS VM in the Open Telekom Cloud console. This takes the most time. We are clicking the things together on the GUI. So there are faster ways to do that. For example, to use Terraform to launch a virtual machine with the AI image pre-installed. After that, once this VM spins up, we can log in using an SSH client to this VM. Activate the virtual environment, as you saw on the previous slides with the Conda activate OTC LabEnv. Then the JupyterLab starts running, and we can begin the developing. In this video, I'm going to demonstrate every single step to show you how easy it is to create a VM, and maybe inspiring those who think it's some kind of complex process. So I'm logged in and choosing the Elastic Cloud Server. This is ECS. So basically, as you can see, it's EC2 in AWS. We have a lot of virtual machines there. We just have to choose the region. As you can see, it's EUDS, so it's a German region. With the specification section, we have to use the GPU accelerated, because now we are dealing with AI stuff, so AI image, which really likes GPUs. You know, the small computations in big batches really fast. I think 64 CPUs will be enough, and half terabyte of memory is also good. We have to choose the Ubuntu public image and the AI frameworks, as you can see in there. AI frameworks is basically the AI image. With system disk, we just have a couple of data sets, so 250 gigabytes will be enough. Let's see the networking section. So basically this section, I'm just selecting some default stuff, because, you know, it just serves this purpose that I can later access this VM from the SSH client. So choosing the network, the VPC, the subnet, the security group, assigning an Elastic IP address again, so I can use this JupyterLab on the World Wide Web. I'm going to name my ECS VM, give it a name like Jupyter lab, and I'm going to generate a keeper, so I leave no steps out. Basically, that's all that you have to do. There you can see that a couple of keepers are already there, blurred, so I'm gonna also name the keeper, so later I will know which VM it belongs. Okay, keeper has been generated successfully. I will keep it secure, and I will download it so I can have it locally. I'm going to refresh it and browse that keeper that I just created seconds ago. And of course, I acknowledge that I have obtained a private key file. I will review my configuration, and basically that's it. So as you can see, the ECS Jupyter Lab that we named it a couple of seconds ago is creating. We just have to wait a couple of seconds. There is a specification and it's already running. So once we have it, you can see that we already have a public elastic IP address as well. There is this GPU tag, which means that our training will be really fast. So I'm opening an SSH client, this time MobiXterm, and I'm going to generate a session with SSH session, where I will specify the public IP address, the name. So as you know, Ubuntu VMs need the username Ubuntu. I'm going to paste in that with small letter, and the one thing that I need is the key pair. So you know, if you don't want to, some nasty guy mine Bitcoin on your VM while you're wondering that why your MNIST training takes weeks, then use keeper. Okay, we browse that keeper, and once we hit OK, we can immediately, as you can see, ECS Jupyter Lab, so we are there. We are going to enter Conda and list to see if from the start we have the Conda environments that I listed a couple of minutes ago to you on the slides are there. So by the first start, it takes a couple of seconds, but they are also already there. These 6 main environments and a couple of things. We are going to activate the OTC LabEnv, and it's already activated, as you can see. OTC LabEnv is in there, and we are going to run Jupyter Lab with the IP address and the port number. So basically that easy to create running Jupyter Lab using the AI image. So as you can see, the token is already there with beginning this C4. I'm going to copy that, use my favorite browser for that to access the Jupyter Lab. I'm going to need the elastic IP address and hit enter. As you can see, it starts this Jupyter logo, and I can start my writing the code of my next big project. I don't know, Facebook, TikTok, or something like that. So as you can see, there is the MXNET, MXNET 1.6, 1.9, OTC LabEnv, Tensorflow 1.15, Tensorflow 2.7, the 2 ByTorch environments. So we have all there. Now I chose this Tensorflow 2.7. I'm going to import Tensorflow STF since I don't really like writing that much. So I can later use Tensorflow, and I'm going to print the version to see if the package is working correctly or not. Yes, so basically this is how easy it is to use this OTC LabEnv demo. So the next thing is this OTC AI image. As you can see, Futuregun is here. Futuregun will be a project that we wrote. It's a type of general adversarial network, but first we are going to install it and deploy it. So it serves as a bridge between the AI image section and the Futuregun. So in this video, you will see how much easier it is, the installation of Futuregun, if you don't have to suffer with finding the right packages, solving the version conflicts, wait for the long installation, and so on. So as you can see, the steps are almost the same as in the OTC LabEnv. The only difference is in the end. So I don't have to use Jupyter Lab now. I have to use this Futuregun training. So let's see it. So again, I'm going to fast forward a little bit. So Elastic Cloud Server again, because you already saw this, the only thing that is different is the UNL region. So now, as you can see up there, UNL is used because it's in the Netherlands region. AI image is chosen, and basically these are all the same. So I don't really want to waste your time. Futuregun will be the name. I'm going to create a keeper. This will be Futuregun. Save it as well. Browse it, acknowledge that I saved it, and yes, I configured it. AI image is there, so I chose the right image. It's already creating, as you can see. Futuregun is up there creating, and in a few seconds I should see that it's running. I should have an elastic IP address as well, and again mobile Xterm where I browse this keeper, Ubuntu, everything like that. And as you can see, I'm going to hit sudo update and upgrade to have the latest greatest from every packages. So now let's rest a little bit, and let's see conda and list if we see the same list as before. Yes, they are also there, so AI image has been installed properly again. And since Futuregun, we used ByTorch 1.10 for that, so I'm activating the ByTorch environment. And previously I pulled a GitLab repo from this Futuregun stuff. So as you can see, there is this run training script. So I only want to show you that the training is immediately running after activating the ByTorch 1.10 environment. So basically this is Python command train.py, and in a few seconds the training gets initialized, and as you can see, epoch 1, epoch 2, epoch 3, epoch 4, so the training is running. So basically this is the really beauty of using AI image. Let's see Futuregun. So you might remember our OTC gun where we had these child paintings, as you can see, these two mountains up here, and our deep learning network converted those segmentation images into photorealistic pictures. After creating and presenting OTC gun at in-house conferences, demo events, innovation platforms, and external summits, we saw that people were really astonished and amazed when seeing OTC gun and this state-of-the-art technology. So we had a discussion with my colleague and co-creator of OTC gun, Zsolt, that we should better exploit, so utilize the power of OTC gun, since this type of deep learning framework is so versatile, uses so innovative technologies, and it's really diverse and has many depths. So we did some investigation, what types of guns are currently on the market. So as you can see on this slide, there are style guns, C guns, conditional guns, cycle guns. There are others like disco guns, just to show and present to you the most popular ones. So as you can see on the pictures, they are used for deepfakes on the Mona Lisa image, so to swap faces or to make them talk things like they never said before, to mix painting styles with each other, to create photos from drawings, and also for face aging, as you can see in the bottom right corner. So these are all cool, but we wanted to create something groundbreaking, useful, and beneficial to show people that technology can be used for good purposes as well. So me and Zsolt both like traveling, hiking, and being in the nature. We both are from beautiful places from Hungary, so we want those places to remain the same. So our children and grandchildren can also enjoy those mountains, forests, and lakes, the same state as they are now around us. So yes, but if you have a look at the current processes of the environment, the record-breaking temperatures in the summers, the drying of our lakes, the lack of rains, the desertification of the southern areas, in 20 or 30 years, our environment will change drastically if we don't do anything. So we had the idea, what if we try to transfer this nature consciousness of ours to people who don't really consider that important the protecting of our environment, but they really like the technology. So that's when the idea of Futuregun was born. Futuregun's main idea is showing the future, so in more details, the user can predict the state of his or her environment in 30 or 40 years if the current climate change gets worse and worse. We couldn't have this, we couldn't resolve this with the OTC gun technology, because this is a nature forecaster, and OTC gun requires two images: a segmentation image, this child painting as you saw, and a photorealistic image, and this is how you train it. But if you think about it, we don't really have the desertifying New York, Amsterdam, or Budapest yet, fortunately. So we should have created these manually, or with the help of some tools like Photoshop or Unity. This was also an option, but we were too lazy for that and wanted a more creative solution. So that's when we asked our two friends, Selenium and Google, to get us a couple of thousands of beautiful nature images and deserts. Then we delete the bad and irrelevant images, clean the ones that need it, utilize some image augmentation techniques like zooming, skewing, horizontal flipping, rotating, using Keras. Start training from these. Hope we get something usable as the output. So that was our plan. But to tell you the little secret, there were a lot of experiments done by us in the planning. So a difficult decision was that which target dataset to choose. So as you can see on this target dataset, so basically the source dataset is the natures. As you can see in the left side, the target dataset are this desertish type of desertificated areas. But we were sure about the post-apocalyptic landscapes, locations and environments. But apart from that, we also had the option, this type of ghost towns, like if you are into video game business, then maybe Last of Us or the zombie show called Walking Dead, or these post-Soviet type places like Chernobyl. So we rather chose this desert type of dataset due to the good style and color transfer capability of Futuregun, but we still plan to give a shot to the other type. So cycle GAN. When looking at the different types of GANs, we found that one that we immediately fell in love with, and this is the cycle GAN. So the main idea and innovation of cycle GAN was that it uses unpaired image-to-image translation. So unlike at OTC GAN, where we needed to create every picture's matching pair, the child painting and the photorealistic image, cycle GAN doesn't need this. So we need a technology like this because, as I said a minute ago, we don't have the desertifying New York or Budapest yet. And then our main goal is to keep it that way, so these images never become real. So transferring characteristics from one image to another is a really exciting proposition if you think about it. Because how cool it would be if you take a photo and convert it into the style of Van Gogh or Picasso. So that is what's happening in the bottom left picture. So you can see this starry dog in there as well. So this image-to-image translation is a class of graphics and image vision problems where the goal is to learn the mapping between an input image and an output image. So it uses a training set of aligned image pairs, but for many tasks, this pair training data will not be available, like in our case in the Futuregun. So these creators of CycleGAN presented an approach for learning to translate an image from a source domain X to a target domain Y in the absence of the paired images. That is the main idea of this CycleGAN. So you can have the question, so how to interpret these CycleGAN results, because CycleGAN, as many other GAN, generative adversarial network based method, it's fundamentally, as you can see in the outputs, it's hallucinating those parts so that it creates. So its outputs are really predictions if what might it look like if. And the predictions, as you can see, they're plausible, but they may largely differ from the ground truth. So this CycleGAN should only be used with good care and calibration in domains where critical decisions need to be done. So this is especially true in medical applications, such as translating MRI to CT data, because just as CycleGAN, as you can see, it may add some fanciful clouds to the sky to make it look like it was painted by Van Gogh or Picasso, but in medical areas it may add tumors in the medical images where none exists, or remove those that do. So as you can see in this slide, the first results, the training results are here by the first Futuregun training. So what you can see is the thing that I said in the theoretical part of CycleGAN. So this is really good at transferring styles, color, and finding the edges. So this means that the most of the lines and edges of the mountains in almost every four nature, source images are pretty good. It also adds some brownish mist or fog to the clouds and sky, which is also really relevant in a post-apocalyptic world. In the first two pictures, as you can see, that it finds and keeps the little river between the two hills, and in the bottom left picture, you can see that it even kept the tree branch in here if you have a closer look in the predicted image. Let's see the later results. So as you can see on this slide, after 20, 30 or more trainings, with a lot of hyperparameter tunings, again, data sets, and we chose a lot of other images and nicer pictures, and those pictures that were a bit, farther from the other ones, we deleted those, and this is what we got. So as you can see, for example, on this one, it's much nicer just to compare with these ones. So I think the users can understand that this hyperparameter tuning is really useful when doing these trainings. The only trouble and the problem is regarding this cycle. Again, if you have a closer look, that it's okay that it transfers the colors, transfer the styles, the characteristics of the images, but no more than that. So if you have a look at the water, for example, it's not really have any intelligence that you would expect from an AI, an artificial intelligence, because if you are in the desert or you walk in a desertified area, you don't really see a lot of waters, but really it doesn't really know what to do with water. So basically it also adds some brownish color to it. So it mostly work, I think, with forests, bushes, clouds, as you can see, mountains and trees. We also created a Futuregun web GUI for that. I will show this to you in a couple of minutes. Basically, we have an online environment forecaster, as you can see on this slide. So the user only have to drag and drop an image, click on the upload, and the upload will convert its nature, which he went out for a walk and took a couple of images and wanted to have a look to get more nature conscious. Then he can upload that image, and our tool immediately converts it into a post-apocalyptic picture. This is the Futuregun Inference part. So this is, I think, also a really good image to demonstrate this one. So the user uploaded this one. This is the source image, and our tool converted this little cabin, this house in the woods in the forest, to this one. So let's show you this page. So it's still in beta phase, so we are still testing it. But as you can see, this website is here. Our slogan is save the nature for a greener future. So yes, our main goal is to try to raise people to be more nature conscious, try our Futuregun, more about us. This is the online environmental forecaster. As you can see in here, you can drag and drop your files in this little box. We also have this little creators of Futuregun where my and Jo's image are there. You can access or reach us via these email addresses. We also have some news where you can read about the current environmental processes, the desertification, the climate change. The Mediterranean region is really affected by the desertification, and some findings about the climate impacts and this stuff that currently happens. So basically we are choosing a file. I will upload this file if you have a look at this one. So if this page loads up, then you can see that from that image we got this one. So again, if you have a look, the rocks are good. The trees, these pine trees are also okay, but again, I think we need some other data sets to train on the water, or use some other guns like style guns. But yes, it's still in beta phase, so are we working on it, but I think we can get some really useful thing about this one. So let's back to the slides, and yes, thank you very much for watching, and if you have some questions, feel free to ask it. Thank you.
Thank you a lot, Ferenc, for this great presentation. So as the next agenda point, we would have here at first now the Q&A session for the part Ferenc has right now presented, and afterwards I would have some information about a campaign which at the moment is running into this direction. So the question is, are there any plans on making the AI image available with CentOS 8, for example?
yes, there are also plans for that, but now our current goal is to test it really on the EU NL region, so in Netherlands, because we really want to make it public there and get the feedbacks and the user experiences if it's working fine, you know, because there are certain things that we still need to test. But after that, so first is Ubuntu, EUD, it's working pretty well. So in the German region, EUNL, I think we are also on good track that it's I think it's a couple of days it's working that, and after that, yes, we can experiencing and brainstorming about applying this and deploying AI image into other operating systems. Yes, thank you for the question. So the answer is yes.
Next question is also here. I see, and it is possible to use AI image via cloud provisioning tool, for example, Terraform.
Yes, thank you for the question. It's really good. Of course, I just showed it to you how easy it is to click on the GUI. Basically, you know, it's much simpler. But if you are rather a coding guy or a CLI guy, like I am, then you are like the easy solutions and the automated solutions. So Terraform, you know, which is a cloud provisioning tool. I think it's the perfect choice for that. So it's much easier and simpler from a coding perspective. If you are a tech person, so absolutely, I think Ansible is also good for that, but Terraform is the best choice. For the Futuregun architecture, is it using the default CycleGAN model, or you have modified to fit your needs? Yes. So the Futuregun model, it's a good question. So let me speak about a bit more. So the CycleGAN, this Futuregun, so originally we found this zebra to horse and horse to zebra. So if you have a look, these are very similar animals, but again, the characteristics, the colors are that is different. So basically, we just have to transfer this white, black, white, black, white, black stripes into a color of this brown that horse has. So this is perfect for the future for the CycleGAN. So this is what we thought about, that, you know, this brownish style we should also transfer. So basically we did some modification on the CycleGAN model, the CycleGAN architecture, mostly to be good for our needs. So it means that, you know, the input parameters and also the image sizes, so we can train later CycleGAN on high resolute images, so HD images. That's our plan. So we modified it, and also later for batch training, so we have that kind of plans. But yes, we modified it, and we plan to modify it much more. I also have a question from Niels. How did you build the actual AI image? My question is if you're also providing the scripts and templates for that. Yes. So Niels, we can send you the GitLab repository where you have also all the shell scripts and Python scripts and everything like that, the installation scripts that we did for the AI image. If it's okay for you, you're welcome.
So we already heard now around 50 minutes long what we can do here with GPU connected flavors here. Some really cool image processing, some looks into the future to see hopefully how the future will not be, to have the possibility to save the future for us and our loved ones who will come after us. So but we already have also other possibilities to use artificial intelligence and, for example, also big data. And this is one use case where you need to process huge amounts of data to then get some elements out of it, like predictions, like analysis, etc. And we are right now having a really cool and great campaign where you get a special offer for these D2 flavors. So the D2 flavors are flavors which are mainly here, you can see it, they are having a attached local disk directly to the flavor. So it's not like you connect the EVS storage to the ECS instances directly attached there to it. So you are having really big flavors there with a lot of additional storage, and the storage is also quite fast, and this empowers you to use these elements here perfectly for all of your big data analysis, etc., which you are running. So for this, we are having right now a special offer. We are at the moment having 6 different options. You can see it here from 4 vCPUs up to 60 vCPUs. The memory is starting from 32 GB up to 540 GB. And here you see these local disks and also the bandwidth, you can access them. So you see, you have here really great possibilities and huge local disks. And we are at the moment giving our customers between 30 up to 70% discount. Yes, we are having here quite big thresholds, like you need to start with 5,000 vCPUs to gain the 30%, but you never know when you are planning here really something big, a big analyze, etc. You can get in contact with us, with our sales colleagues or our FMB, etc. And there you can find all information about how to book it and how you get these discounts. And just to inform you roughly about the small discount, the 30%, when you would use, for example, 84 times the largest flavor which you are having, you would save over 138,000 euros per month. And with the biggest element here, so with 500, that you are in the biggest discount group, you would save almost 2 million euros per month. For sure, you also still need to pay then 800,000 euros, but you see, instead of 2.8, you just pay 0.8 million. So I think when you are in this big scenario, then for sure you can save here a lot of money. So for this, also from my end, one more time, thank you a lot for joining us here in this presentation, in this webinar. We also have for this campaign a landing page, which you can see here. It's open-telekom-cloud.com/en/d2, where you can read out all of the information, which I just now presented also on the whole page view. And really down below, when you are interested, you can get in contact with our product owner from the Big Data and AI Squad, Hector Lopez. You just put in here your contact details, and then we will get in contact with you. Thank you a lot for joining us in this great webinar. Thank you, Ferenc, for having you here, presenting us the topic about the AI images, and hope to see you all in the next webinar, which would be, as usually, the last Friday of the month, 10 a.m. to 11 a.m. So same time again here. See you next time again. Thank you. Bye.
Thank you. See you.
Thanks. Bye-bye.
Thank you very much. Bye-bye.
Bye.
Much appreciated. Thank you. Bye-bye.
Thanks. Bye.